few topics that I think are really important, and we got a few more today. We're talking about canary automation.
Yeah, and I think this is going to be interesting because, like, like I try to say these things without being completely biased. I mean, like, people look at the logo on my shirt and they're like, yeah, well, like, of course he will say this, but I genuinely try to look at these things from the perspective of a practitioner, because that is what I am. I am a practitioner,
Yep.
right? I'm same with yourself. We've been building software, and I really think that Service Mesh is a good piece of technology, and I really think it's a great piece of technology for developers, and I'm excited to be able to share this sort of stuff. So, hello everybody who's watching. If you're watching live, we will record everything here, and we will be showing this later on. It'll be available straight after we finish recording, so don't worry if you miss out on anything. Service Mesh for developers and Canary deployments. Canary deployments, I think in general, something which is quite challenging to do, and I think pretty essential as well. Why do I think it's essential? So I'll give you my view, Christian, and then you can maybe give me your view on why you like him.
Yep.
I like Canary deployments because I'm going to put my hands up in the air and I'm going to say I make mistakes occasionally. And I don't do it deliberately.
No,
it's true. It's true. I know you'll never normally hear me admit that, but occasionally it happens. And I think for me, the core reason is that you have a drift between features and tests. So we all like to take a test-driven approach, but your code is only as good as the tests. So if you've got missing tests, you've potentially got missing code. And if you've got missing code, you could have bugs. So I think there's a lot of edge cases which can kind of manifest, which is why just a straightforward, even testing, integration, and manual testing approach can miss. So with a Canary deployment, what we're going to do is we're going to slowly release to account for the unknown unknowns.
Yeah, absolutely. Another thing I'll point out is that your testing might and hopefully catches functionality bugs, but what's very difficult to simulate and test is environmental bugs.
Yeah.
And specifically production environmental bugs without being in production.
Yeah.
Right. So I think what we want to do here is I can't remember who first. I think I saw this on the Turbine Labs was a startup a little bit back that was building a platform for Canary automation, and they did a really good job describing the separation of doing a deployment from doing a release.
Right.
Where traditionally, we would kind of commingle those. When we put something out and deployed it, it was live, right? But if we could separate out the step of deploying something into production and then making it live,
yeah,
then we have more control over being able to do testing in production. Although the phrase might be scary, what we're doing is validating something after it's been deployed into production in the environment in which it's running, before we actually expose that to customers. And then when we do expose that to customers, we do that, like you were saying, incrementally and in small chunks, right? So the aperture that a user sees of any of these new changes isn't just there, right? When we make it do the deploy, it's slowly being released. So we're able to separate out those and more in a more controlled way, manage the possible, the what ifs, the unknown unknowns of making changes in production.
Have I ever told you about the time when I deployed a new version of a payment service, which was perfectly tested, had full test coverage, and took the entire payments operation for the organization offline?
No.
Okay, then it didn't happen. But if it did happen, then maybe that would have gone offline because of a configuration problem rather than an application code problem.
Yep.
Just saying.
Yep.
If it did happen,
it could have.
It happened. That's what it could have been. Let's dig in.
Yep.
So what? Let's kind of spin things up. So we're going to look today at Canary deployments. We're going to look at how we can do that with Kubernetes and Service Mesh. So the first thing that I need to do, I need to just kind of spin up my environment, and I'm using the tool that we've been using right the way through the series, and I'll show you these in a moment. But I'm just going to create my dev environment. So I'm just going to run everything locally on my Docker environment on my PC here. So what is that environment? So what we are doing is we've got this code repo here, which we'll put in the link down there, but we've been running through this over the last few weeks, and we're up at Canary Deployments. And we've tried to build this in a way that you can kind of take this and experiment and play on your own. But we're using a tool called Shipyard. It's a very elegant Bash script with all the bugs you'll expect in Bash, but it allows you to spin up Kubernetes clusters just in Docker. So they're completely disposable and they spin up really, really quickly. So Canary,
which is awesome. By the way.
Yeah.
It simplifies setting up this environment, especially when you're deploying service meshes and all these other. I mean, the Shipyard tool is great for this.
There may be some good stuff coming, but we'll maybe save that for another day. But yeah, I think this is kind of like the key thing about anything that you're doing as a developer. You need an efficacy in the work. You need to be able to kind of work effectively, quickly. You need to be able to destroy environments, and you don't want any barriers. So it's really difficult with microservices and large cloud technologies, but I think the tooling's kind of trying to slowly kind of creeping in that direction. So Canary deployments, don't take our word for it. 2014, and I always think that Martin Fowler, anything associated with Martin Fowler is a wonderful place to start and end when it comes to information. And there's a great article here written by Danielo Sato, who on Martin Fowler's blog about Canary releases, 2014, right?
Yeah.
But the cool thing here is that it's sort of it's this approach. It's this ability that you have two versions of your code running in production at any one time, and you are controlling the amount of traffic that goes to each version, and that you can control that gradually. And this is exactly what we're gonna show you today. It's really easy. In 2014, I wouldn't have liked to have done this. I don't know about you, but personally, I would have accepted that outage in the payment service to save the pain of trying to roll this sort of process. Today's technology, today's tooling, very, very different.
That's the key. That's the key, because these patterns have been around for a while. Amazon, I remember Amazon was doing this. Facebook's been doing this for 10 years. But they had a lot of they custom built their platform.
Right.
And they had these capabilities in them. We, in the open source and sort of the next generation of these technologies, it's becoming more approachable and something that we can actually do.
Yeah, and I think this is kind of the key thing that that really sort of excites me. It's the accessibility, and I think that's why I like to talk about this from a developer's perspective, because it's not just you've got to have. If you're a recruitment consultant, like I don't know, I would say 30 years DevOps experience or something like that. That would be fair, right? To be able to do this, but you can learn these and use these techniques very, very easily. So I've got everything spun up. So here is my Consul server. So I'm going to be using HashiCorp Consul to demo this. Other service meshes are available, but Consul is the best one, obviously. But we're kind of, I joke about that, but realistically, the techniques that we're going to teach you today are sort of, it is possible to use other service meshes to do this. We're kind of, but Consul's still the best one. Anyway, So I've got my thing. So I need to install my application. So what's my application going to look like? Well, I've got a bunch of Kubernetes configuration files. So let me apply those. kubectl apply -f app. And I'm just going to throw this entire bundle. And while that's applying, I'm going to show you what that bundle is. So I have a payment service. I have an API. And I have a web service, and I've got some tracing. I'm using Jaeger to capture my tracing information. So the way that this is all kind of glued together is that web talks to API, API talks to payments, and payments talks to currency. And when we kind of look at that in the UI, let me just refresh my, I need to kubectl port forward quickly. Let me just access that pod in my local cluster. So when I look at things there, you can see the kind of the chain of calls very, very sort of simply showing up in my dashboard. And I can see web is hitting API v1. I've got everything coming out in my traces. And if you've missed sort of the episodes when we were talking about tracing, you can, and I also need to kubectl port forward that one. You can find those, and we'll share those in the description, but last week we were talking about tracing and how that works and what it means for you as a developer, but all of my application is enabled for tracing, and you can see here the flow. So I have my web, my API that calls an upstream of payment, etc., and then I've got currency as well, which is called in that mix, and everything's working there quite nicely. If we look over here in Consul, again, I can see all of those services are registered. So we've kind of talked about the approach of the sidecar and things like that, so I'm not going to go into that again. We will share the video, much more interesting. But you can see here in my application stack, and I have my Consul annotations for Kubernetes, and I'm just defining these upstreams. I'm kind of saying that, hey, web needs to talk to API, and I would like API to be available on port 9091 at localhost. So a lot of folks will look at this and say, well, hey, like Kubernetes has service concepts as a primitive. Why does Consul Service Mesh not sort of tie into those? And the main reason is that Consul Service Mesh is designed to be platform agnostic. So we work great with Kubernetes, but the aim is to kind of provide a heterogeneous, you know what I mean, a mixed workload. You had it, yeah. Yeah. So we'll work on VMs and all of the things. Right. So we got that there. It's all good. It's all working. So let's go through a simple scenario. So the scenario is that I need to change some application code, and I'm going to do a deployment. Okay. So let's have a look at my application code. Digging into my payment service. So in my payment service, what the app team has asked me to do is to redeploy. So rather than using the standard net HTTP library in Golang, which looks like this just there, what they've done is the platform team has actually developed their own HTTP client, called custom library. It's supposed to be pretty good. So I've been asked to deploy it. I'm just going to do as I told for once. So let me substitute that. So their new library, they've called it Sleepy, and it looks fairly good. I mean, the interface is exactly the same as net HTTP. But let's just build that and deploy it. So I would ordinarily, I'd commit my code and I'd push that to CI. I'm gonna cheat ever so slightly by running the build on my local machine, but you can assume it's doing the same thing. So I've just done my code build. I've built a Docker image, and I can now push that Docker image to my cluster. So with one of the nice features of Shipyard for running our local images is we can develop everything locally, and we can just push that image up to the local Docker registry in our Kubernetes cluster, so that we don't need to push it off to a remote registry or anything like that. It's just a little bit more efficient.
Yeah, that's super handy.
Right. So now our next step, well, we've made our code change. I guess we should probably just update our payment service with the new version, right? So let's just do that. I'm going to run version 3 of broken service. A lot of people have faith in my code calling stuff broken service. I don't know. But let's deploy that. So again, I'm literally just going to kubectl apply that app folder. And remember to type apply as well, just for kicks. So that's running. So now we can kind of, while that's running and that's deployed, let's test our service again. I've just gone for a cup of coffee. I've walked away from the screen. I've done everything that I should have done around a deployment because my code never fails. I've got somebody on the phone, Christian. They're saying that the new service is broken.
I can't be. Tell them to check their service.
Yeah, exactly. It can't. It can't be. It does definitely look broken though. So I'm going to check my logs. Let me check my traces. And sure enough, it's looking broken. So let me dig into this. I can see here that the call upstream is broken, and I know that the chain is API to payment service. So let's dig into those logs. What do we got going on here? So the tracing is telling me that error communicating with upstream service, net canceled, timeout waiting headers. Okay, problem. So I'm going to do what anybody would do, and that is very, very rapidly, I'm going to roll back that change. I'm going to reapply things. I am going to pretend nothing ever happened. Fingers crossed when I refresh this, it's back to normal. So nothing ever happened there, didn't break. Honest. But I think that, the core problem is that I've gone through that whole process. I've tested that service. I've checked my code. I've got my unit tests. I deployed it to production and it still broke.
Right.
So is there a better way? And there is, and that's to use the Canary-based approach. So what we're going to do is something like this. So we have our web service, and our web service is going to route between API version 1 and API version 2. Technically, API 2 and 3, and we're using Consul Service Mesh to be able to do this. I don't need to code anything into Nginx. I don't need to code anything into any other of the API gateways or anything like that. I'm just going to do this all through configuration because I'm already using Service Mesh. And it's nice and easy. So let's take a look at what that's going to look like. So what I need to do is I need to apply some configuration. So I'm going to use some central configuration called a service resolver, and this is part of the layer 7 configuration in Consul, kind of the stuff that allows you to do this very sophisticated routing and splitting. And I'll post a video down below of some more sort of in-depth discussion around that. But this is what it looks like. So I've got this very simple configuration file. I think it's very straightforward to understand as a dev, and I'm happy interacting with it. But I have a service resolver, and it relates to the payment service. And then I'm defining these subsets. So I'm going to say the default subset is blue. Okay. And then I've got this list of subsets. So I'm defining a blue subset, and I'm saying service meta version is 2. Okay, so that makes it a blue subset. And then service meta version 3, that makes it a green subset. What's that all about? What that is, that corresponds to the service metadata. So in Consul, you've got the ability to add metadata to a service. So if we look at our payment service here, you can see that I have metadata. It has version of a value 2. So then what that will do is if I look at my subset, service meta 2, it's going to attribute that and it's going to put it into the blue group. I don't have any green services running at the moment, and that's fine because by default, all of my traffic is going to go to blue. So what I can do is I can apply this configuration, I can deploy my service, and it'll be sitting there on the cluster, but it'll be inactive. So let's give that a whirl. So how do I apply that service configuration? So there's a number of different ways to do it. I can use APIs, I can do sort of CI or anything like that. But like as a developer, what am I going to do? I'm just going to use some command line tools to interact with a cluster. So I'm just going to use the Consul CLI tool. It's very lightweight Go binary. So to deploy my service resolver, I'm going to use the command consul config write and payment resolver. And that's it, it's done. So that's now written to Consul, and I can I could check that out and do consul config list, and then it's service resolver. And you can see I've got that there, it's been written. But what I'm really interested in doing is deploying a new version of my service. So when I look at my existing blue service, I'm using these Kubernetes annotations. So I've said that service meta version of 2 and service tags of 2. And what that does is those annotations are setting the metadata inside of Consul. Because the metadata is set inside of Consul, I can leverage them for those layer 7 configurations. So I'm going to now define a brand new version of this because I want this one to exist. I want that pod and that deployment to exist in there. But what I'm also going to do is I'm going to deploy a green version. And my green version has a meta version of 3. It's using my v3 service. And if you just quickly bounce back to that resolver, see, green is meta on v3. So let's deploy that service. So kube ctl apply -f payments green. And if I have a look at my sort of Kubernetes setup, you can see I've now got those 2 deployments. I've got my blue instances and my green instances. Bounce over here to Consul. And if I refresh this, if you look now when I click on the payment service, I've now got 2 instances. So I've got the blue instance and I've got the green instances. The blue instances, metadata version 2, and the green instances, metadata version 3. Now over here, just refreshing my fake service there, and I mean that's working perfectly fine. And it's working perfectly fine because all I'm doing is I'm hitting the sort of the blue version of my service, which is sort of by design. So I'm cool. So the next thing I need to do is I need to start to gradually roll out that service. So how do I roll out the service? Well, I'm going to use another piece of configuration called a payment splitter. So what the payment splitter allows me to do is define the weights of my service traffic. So I can say, hey, 50% of my traffic, send it to blue. 50%, send it to green. Now, I would normally say at this point that I never make mistakes. So 50-50 split for me is totally fine. But I've already admitted that that's already a lie. So I would generally kind of take a little bit more of a conservative approach on this. And I think it depends on the traffic that you send to your service, but you want to start very, very low. Maybe start with 1% of all traffic and slowly increase it, or increase it in increments. We're just going to go straight 50-50 because it's like if I have to refresh my browser 1,000 times to get this to work, it's going to make for pretty dull stuff, right? But let's do that. So 50-50. So how do I apply that? I apply it exactly the same way. So I'm just literally just going to do console config write, and I'm going to do my payments splitter. Oh, sorry. I just need to apply also my service defaults. The reason I need to apply my service defaults is because I need to tell Consul that I'm specifically going to be using HTTP for my services rather than what was previously just TCP. Normally we just have these as a global. So writing the payment splitter, there we go. And well, let's have a look. Oh, it's looking broken. It's hitting my bad version of my service. Oh, but half of my good service. And I can refresh that. Nope, I'm hitting the bad one again. So what I'm doing now is I'm kind of balancing that traffic, and it's an approximate 50-50 split. Over time, it would be very, very close. But not every instance is now hitting the bad service. Again, what this is allowing us to do is to detect that there's a problem running in production. Again, I can use my monitoring and my observability to be able to kind of do that. I am just kind of hitting that 50-50, as I say, for demonstration purposes. But you can clearly see that I have deployed something and there is an intermittent problem here. So I need to roll it back. So when I rolled it back before, what I did was I changed the deployment, but I literally affected 100% of my traffic. Well, to kind of roll it back this time, what I'm literally just going to do is just roll back the traffic. So I'm going to go 100% on blue, and I'm going to go 0% on green. And I'm going to apply that payment splitter. So let's have a look. That will have immediately taken action, and that's one of the nice things about Service Mesh. You don't have to wait. So there.
One thing I want to point out is that it's doing it at the request level.
Right.
Right. It's doing it at the L7 level. Other load balancers that may operate at a lower level, they can only balance out the connections and kind of put them, load balance the connections and apply weighting to them at the connection level only.
Yes.
Whereas here, Consul Service Mesh is able to look at each individual request and then do the weighting based on that.
Yeah, and it's just easy. I mean, I think two very, very simple configuration files for something which is a very sort of powerful feature, I think.
Right.
And that's pretty much it. That's Canary load, like canarying on Service Mesh. I kind of feel let down that I don't have anything else to show people, but maybe that's a good thing because
that's fine. That's why we're doing these in different different
nice segments, and easy.
Right? Yeah.
But again, let me just let's say I make another little change here and I change my weight back. I can just write that payment splitter. It's very, very fast to act, and then I'm going to hit it like 90% of my traffic's going through to my main, so you can see that's working most of the time. And then, oh, there we go, I've hit a bad one. 10% of the traffic is going to hit the sort of the faulty instance. You can kind of configure those balances depending on the traffic, your service, the importance of your service, how confident you are in the deployment, all of those things. But I think it's a really, really nice and elegant way of doing deployments. And again, what does that mean for a developer? So I think we kind of touched on this last time, and I kind of want to, this is my parting thought, if you will, is that I think that something like service splitting for a canary is an application concern. And if it's an application concern, it's owned by the application team. Now, if you're a larger organization with multiple teams, then I think it's fine to say that you will have operations people and developers working together in that DevOps mindset. So you will have specialists in your team, but as a developer, we should understand how this works, because we can actually leverage this to our advantage. And really, it's very straightforward. It's not like you've got to kind of demystify systemd and good luck with that. I'm not helping.
Right. Yeah, so that's all good. I think in some of the next sections or the next series, the next episodes, I mean, we're going to build on this where we saw errors. You know, what do we do? How do we debug them, right? And how do we do that from a developer's perspective, not just troubleshooting, but actual debug?
Yeah.
And we'll be looking at that in the next few episodes.
Yeah, I'm pretty excited about this, because I think we kind of complete the circle with the next show, which I think is next week. We are going to show you how to debug your services in production. So in this example, it was pretty straightforward. It was fairly easy to see where the problem was, and the tracing helped me out a lot. But sometimes you have, and I think more often than not, the sort of the problem is the input which leads to an issue. It's not necessarily so clear. You can put valid input into a system and it performs amicably. Generally, those are your known test cases. And you can put bad input in, which you've crafted to be bad, and it works amicably. But it's that unknown input, that strange manifestation, and being able to live debug and do all of these wonderful things that you're going to show us with Loop and Squash next week. I'm pretty stoked to see all of that.
Yep. So definitely join us for the next episodes, and we look forward to it.
As always, it has been a pleasure, Christian. Thank you so much for taking the time to join us today, and I hope you all have enjoyed. Hey, by the way, we got to say this, because you got to get used to this. I've been researching this. Like and subscribe, and all you people who are watching, smash that bell button. Like, I get paid on likes, and I've got 5 dogs and a mortgage. If I don't get my likes,
so we need those likes. Yeah.
I don't get paid on likes. I would never.
I was going to say, I need to figure that out.
Yeah. But thank you so much. I hope you've enjoyed this, and please do comment down below if there's anything that you would like us to cover. And until next time. Take care, Nick. See you later, buddy.
See you next week. Yep. Yeah, bye.